Hey students, welcome back. Today we are discussing the 5 most common confusing questions from the chapter of moles, chemical calculations. These questions are from the year 2024. Let's get into them. Organic compounds contain hydrogen atoms. Calculate the number of hydrogen atoms in 44 grams of the ester methyl propanoate. So we have the mass of methyl propanoate, which is 44 grams. And the ester formula is also given. 1 mole of this ester, methyl propanoate, contains 6.02 into 10 power 23 molecules. Give your answer in the standard form. Now, what do we need to calculate in this? We have to calculate the number of hydrogen atoms. Whenever we have to find out the number of atoms, molecules, particles, or anything, then we have to multiply the value with the Avogadro's constant. And then we'll get the answer. Now, with which value we will multiply, that's the thing. We will always relate the Avogadro's constant with the number of moles. Whenever we have to find the number of atoms of any substance, then we will relate it to the number of moles, because 1 mole contains Avogadro's number of particles, Avogadro's number of molecules. So first of all, we have to convert the given mass into the number of moles. Let's do it. Number 1, first step, we'll convert this into the number of moles by doing it with the formula moles is equal to mass over mR. Now the mass is given to us, which is 44. Molar mass is not given, so we will find it out. 1, 2, 3, 4. There are 4 carbon, C4. Hydrogen, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 hydrogen and 2 oxygen. So we will calculate its MR. It's going to be 12 into 4 plus 1 into 8 plus 16 into 2. Now let's calculate. And MR comes out to be 88. So we'll do 44 divided by 88, and the answer is 0.5. So the number of moles in 44 grams of this ester are 0.5 moles. Now what we'll do in step number 2, we'll multiply these number of moles with the hydrogen atoms present in the formula. As we can see in this formula, there are 8 hydrogen atoms. 8 atoms of hydrogen present in here. So these hydrogen atoms are present in 1 mole of this ester. So in 0.5 mole of the ester, how many number of atoms will be there? We'll multiply this 8 with 0.5, and the answer is 4. Now we have the 4 number of atoms in 1 mole. There are total 8 atoms. So in 0.5 moles, there will be 4. Now, in the last step, we'll multiply this 4 with the Avogadro's constant. 4.02 into 10 power 23. We'll multiply this with 4. And the answer is 2.408 into 10 power 24. This is our answer of this question number of hydrogen atoms. Next question is from October-November paper. This question is about the compounds of tin. Tin, its symbol is Sn. Tin oxide has the formula SnO2. The relative formula mass of tin oxide is 151. This is the MR of tin oxide. Calculate the percentage by mass of tin in tin oxide. Now, when we have to calculate the percentage by mass of any substance, we'll use the formula percentage by mass of the element, which is tin here, is equal to mass of that element divided by the MR of the compound. Here the element is tin, so we'll find out the atomic mass of tin and we'll substitute it in the numerator. The atomic mass of tin. Let's see, what is the atomic mass of tin? The atomic mass of tin is 118. This is the atomic mass. So what we'll do, 118 divided by 151 multiplied by 100, because we have to find out the percentage. We'll multiply it by 100. 118 divided by 151 multiplied by 100, and the answer is 78%. This is our answer. Next question. Determine whether zinc or sulfuric acid is the limiting reagent. Now we have to find out which one is the limiting reagent here. For that one, we need to understand the limiting reagent first. Out of the two reactants, one of the reactant will be in the more amount and the other reactant will be in the less amount. The substance which is present in more amount is known as the substance in excess, and the reactant which is present in less amount is said to be limiting reactant. Because it is present in less amount, so it will be completely used up. So we have to see that which of the reactant will be completely used up during the reaction, the one which has less number of moles. Now, how we will identify it? We'll take out the number of moles of both reactants. So here the reactants are zinc and sulfuric acid. So we'll take the ratio. For the zinc, the number of moles we'll calculate from here. The grams are given to us. So we'll do moles is equal to mass over molar mass. For zinc, the mass of the zinc is given 0.325 and we'll divide it by the molar mass of, or the atomic mass of zinc. The atomic mass of zinc is 65. We'll divide with it. 0.325 divided by 65. So it's 0.005. So the number of moles of zinc are 0.005. And for sulfuric acid, they're given in the question, which is 0.01. Now, these are the number of moles for both substances, both reactants. We have to divide them by their coefficients. Now, in the balanced chemical equation, we have 1 mole of zinc and 1 mole of sulfuric acid, 1, 1. So after dividing by the coefficients, the answer came out to be same. So as you can see, that zinc number of moles are less and sulfuric acid number of moles are more. So that means that zinc is our limiting reagent. Limiting reagent. So first of all, we have to write that zinc is the limiting reagent. And then we have to explain our answer. Now, how do we explain the answer? We'll write that zinc is the limiting reagent. Zinc is the limiting reagent because moles of sulfuric acid, H2SO4, moles of sulfuric acid are greater than the moles of zinc. So that's the simple answer. But we have to show our calculation also. Next question is the part 2 of the same question, which is October 24 paper 43. Question number 4, part F, and this is the second part of the same. Now, in this question, in another experiment, we have the volume of hydrogen gas given, which is 48. This much volume of hydrogen gas is produced. The experiment is carried out at room temperature and pressure. Calculate the number of molecules in 48 centimeter cube of hydrogen. The value of Avogadro's constant is this. So as I said before, whenever we have to calculate the number of molecules, number of atoms, or the number of particles, formula unit, everything, we have to relate it with the number of moles. And then we'll multiply these number of moles with the Avogadro's constant to find out that how many total molecules are there. So here also, let's convert this volume into the moles. We have the formula moles is equal to volume over molar volume. Here the volume is 48 centimeter cube and the molar volume will be 24,000 centimeter cube. Why we're using 24,000 here? Because the volume is given in centimeter cube. If the volume will be in decimeter cube, we could have used 24 decimeter cube, but if it is given in centimeter cube, then we will use 24,000 centimeter cube. Now, let's do it. 48 divided by 24,000, it is 0.002 moles. This is our step number 1. Then in step number 2, we'll multiply this 0.002 by Avogadro's constant. And it will give us our number of moles, which are 1.2 into 10 power 21. This is our answer. Now we have this question in which we'll find the empirical formula and molecular formula of from the given substances for the given atoms. Here we have been given the percentage of carbon and the percentage of hydrogen, and we'll calculate its empirical formula. This is compound A. So let's do it. To find out the empirical formula, we will find out the simplest whole number ratio between the two elements. To find the simplest whole number ratio, there are certain steps which we have to follow. For the first one, in the first step, we'll calculate their number of moles. So for the carbon, the mass is 82.76, and for hydrogen, the mass is 17.24. We'll divide the masses by their atomic mass, which is 12 for carbon and 1 for hydrogen. For carbon, it's 6.89, and for hydrogen, it will be 17.24. This is going to be our first step, to find the number of moles. Now, when we find the number of moles, we have to do the second step by dividing them by the least number. Here, the least number is 6.89, so we'll divide both of them by this number. For the carbon, it's 1, and for the hydrogen, 17.24 divided by 6.89, and we get the answer 2.5. Now, as you can see that the hydrogen answer is 2.5, it is not coming in whole number. So we will multiply both of them by 2 to convert them into whole number. If we multiply 2.5 from 2, we'll get the answer 5. So carbon will be 2 and hydrogen will be 5. We get the whole number. So the correct answer, the empirical formula will be C2H5. For the compound B, the empirical formula is given CH2 and the relative molecular mass is 70. Determine the molecular formula of compound B. We have to find the molecular formula. For the molecular formula, what we'll do to find it, we will multiply a number n with the empirical formula CH2. Now, how to find this n? We'll do step number 1 to find the value of n, which is, we'll take the molecular mass in the numerator, molecular mass, divided by empirical formula mass. The empirical formula is given to us in the question, which is CH2. We'll find out its molecular formula. CH2 is equal to carbon is 12, hydrogen 1 into 2. 12 plus 2, it's going to be 14. So we will do a molecular formula. Molecular mass is given in the question, which is 70 divided by 14. And the answer is 5. We'll multiply this CH2 with 5 CH2, and the answer is C5H10. That's the answer of molecular formula. And in the previous part, we calculated the empirical formula, which is C2H5. These are the 4 questions, 5 questions. Then consult the next video for the part 2.